is going to have a look at the difference between complete and incomplete combustion, and I'll start with a quick story. So a few years ago my parents got a log burner for the lounge. They put it in the chimney, and one night they turned it on. They started feeling very tired. They thought it was just the atmosphere it created, the low light and the fire in the background, and they started feeling very tired, so they started to drift off. My dad very sensibly got up, turned the log burner off and went to bed. Very fortunate he did that, because what they found a few days later was that a bird had actually managed to get stuck in the chimney flue. Had they not gone to bed, things could have been a lot worse, and there's a very good reason for that, and there's a very good reason why they were feeling tired as well. So let's have a look at this idea of complete and incomplete combustion. If I take two molecules here, so I take methane, which is smaller, it's just 1 carbon and 4 hydrogens, and I take pentane, which is 5 carbons and in fact that's pentene, so that's 5 carbons and 10 hydrogens. I need to balance this as an equation. So in order to do that, I normally go for the carbons here and here. They're fine. So carbon, they're balanced. I'm going to leave the oxygens until the end because they're in 2 molecules over here, so I'm going to go to the hydrogens. So I'm going to balance out the hydrogens to start off with. That means I've got 2 oxygens here, I've got 4 oxygens here because the 2 and the oxygen. So that means I need 2 of those to give me 4 oxygens here. So that means for every molecule of methane, I need 2 molecules of oxygen. If we go down here and have a look at this equation, now this is a little bit different. So I'm going to need 5 carbons there, right? Over here, I'm going to need 10, 2, so I'm going to need 5 waters as well, because 10 divided by the 2 is going to give me 5. So when I balance that out, that's going to be, that's going to be 5, okay? Which means that I've got 5 times 2, so 10 oxygens, plus 5 oxygens, so I've got 15 oxygens, which means I've got 7.5 oxygens over here. Okay, so I've got 7.5 oxygens. That means I've got over 3 times as much oxygen needed to combust 1 molecule of that. That's not actually necessarily possible, because I've got to have, I've got to get more oxygen to each molecule in order to get the carbon dioxide and the water. Carbon dioxide isn't actually that bad in comparison. So let's say we can't get all 7.5 molecules of oxygen over onto this pentene molecule. So what we're going to have to do is we're going to have to remove oxygen from the left-hand side. And the oxygen going to be removed from the left-hand side is going to be here. Okay, which leaves me now with carbon monoxide, CO. If there's even less oxygen, I will get carbon by itself, so soot. Now, both of those are really bad. Carbon on its own, soot is very bad for the environment. It's a black powder. It's responsible for a lot of sort of environmental issues in the past when we used to burn coal in factories. Carbon monoxide is much worse than that because it's poison. It's a colourless, flavourless, tasteless, odourless poison, so you can't detect it. And many of you will have a carbon monoxide detector in your house now, and because you can't detect it, it gets into your house and then you breathe it in, and what it does, it attaches to your red blood cells and it stops oxygen bonding to your red blood cells, it stops oxygen getting around the body, and as a result you suffocate, and that's why you would all tired. So my parents, what they were doing was they were actually breathing in carbon monoxide and they were getting very tired as well. So why is this? Well, if we have a look at the 2 molecules, these are slightly different. So this is what methane looks like. It's just 1 carbon and 4 hydrogens around the outside. If I'm an oxygen molecule, I'm going to find it very easy to find access to this molecule. So this is the easiest way of explaining. If I have 7 oxygen molecules, which are all looking sort of like this, well, actually, I'm starting to run out of space on my bigger carbon. In the previous case, this was pentene, but this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is dodecane, so it's over twice as big. You're going to struggle to get access of the oxygen to this. So this is why when you burn things like wood, which are very big molecules, you get a lot of soot, whereas when you burn the gas in your house, so gas that comes from the hob or the stove, you don't get black soot everywhere because it's a very small molecule, so it it goes through complete combustion instead of going through incomplete combustion. There is not enough oxygen available to react fully and produce just carbon dioxide and water.